ladies and gentlemen, please welcome Vice President EMEA, Google Cloud, Sebastian Marot.
So much, touching so many in so many different ways. Our frontier is financial technology. It's changing the way we work, make money, and the way we trust each other. To succeed, we need to adopt the mindset of the Silicon Hubs of the world and create an incubator of free thinkers, thought leaders, innovators born of collaborative spirit, all fueled by a belief that technology will enhance our customers' financial lives. To imagine a future beyond what we already know, creating a team with the power to transform the world's leading financial enterprise. We are technology.
Good morning. When you work for one of the world's largest banks, you get used to dealing with some very big numbers.
We've got DLP API doing data minification on this. So what you can see is my name has been removed. It's identified as a first name. We've also got the customer's name, Angela, has been removed also. Her phone number has been removed, and her national insurance number has been redacted also. But it's more than just plain text. You can see here the passport, we've removed her face, and all the information from the passport that we determined was worthy of being minified.
Great, so now this archive data is safe.
Okay, sorry about this. For that reason, we've actually been integrating Firebase more closely with Google Cloud, right? And with that, you can now actually access services inside of Google Cloud using the Firebase SDKs. And Firebase has emerged to be a really powerful framework, and it's already used. 1 million projects were created on Firebase just last year. So part of what we've done is we've integrated it with Google Cloud Storage. So now with a Firebase developer kit, you can access any GCS bucket in any region around the world, and you can actually, from your mobile app, you can upload and download objects that are living in Google Cloud Storage directly. And we've also added analytics. Analytics are built into Firebase, and users use those, developers of apps use those to understand their user engagement. But what you can do is you can then take the data from Firebase Analytics and you can export it into GCP. And when you do that, you can actually ingest it, other data sources into BigQuery and Data Labs. And then you actually can get an even richer view across your user sentiment. We also integrated Firebase into Google Cloud Functions. And what that allows you to do is Cloud Functions allows you to extend the backend service of Firebase. And you can extend it based on many key events. It could be an event that when a piece of object storage is accessed, or a new Firebase auth request comes in. And then these events fires in Cloud Functions, and you can use them to send a push notification. You can use them to invoke a machine learning process on a piece of data. And then lastly, because we like lawyers almost as much as we like developers, it was completely different contracts when you use Firebase and you use Google Cloud before. So we've integrated them into a single terms of service, and then soon you'll be able to use largely the same contract for Firebase as you do for GCP. And we'll be making more integrations over the coming months with Firebase and Google Cloud. And now Greg is back, this time with Martin. He's going to show you how GCP and Firebase can be used for sitting in front of legacy apps also. Greg.
Thanks, everyone. As Brian mentioned, we're going to show an example of taking a fairly typical on-prem enterprise application and how we can modernize it and move it to the cloud sort of all at one time. Now, the application example that we're going to use is a pretty typical Microsoft ASP.NET application, the kind of thing you'd see in corporations all over the place. In this case, it's an example of an application that an insurance company might use, where the adjuster goes out, they take pictures of a car accident, they upload the photos with their laptop. The app also has an API on it so that you can manipulate and control the images that are stored. So we're going to start with this by modernizing it and creating a mobile front end so that our agents actually can be out in the field. And what better way to create a mobile application than with Firebase? Firebase makes it possible to create a cloud-powered back end without even having to spell cloud. It allows client-side developers to easily create cloud-powered applications. Now, one of the powerful things is that Firebase integrates with cloud storage. So the line of code that Martin has highlighted here is the line of code that will use the camera on the phone, take a picture, and upload that picture into a cloud storage bucket, a GCS bucket. It's really just that one line of code. So to show you that this actually works, why don't we switch over to the phone on the screen. Martin has this Firebase application running. He's going to take a picture of all of you just as a test. So he takes the picture, he uploads it, and the gods of corporate Wi-Fi are pleased, so it is uploaded. And now to show you that it really is uploaded, that he'll switch over, let's switch back to the laptop, and he's going to list that bucket. Now, you Windows developers and admins out there will recognize he's using PowerShell. So he's using Google's cloud tools for PowerShell, which give him a very PowerShell-friendly way of interacting with cloud resources like storage and compute and network. So in this case, we do find that there was a picture that was updated this morning. Great, so we've got the application. We have a mobile app, it uploads photos. How do we connect those photos that are in GCS to this legacy ASP.NET application? Now, the good news is I mentioned that this application has an API. The bad news is this application was probably written sometime around 2000, 2001, which means it's probably a SOAP API, not a modern RESTful one. So let's see if we can take this application API out of Spice Girls and make it more Ed Sheeran. So we'll start by using Apigee. Apigee is a really complete enterprise tool for API management. I could talk for a long time about Apigee's capabilities. I'm going to focus just on a couple. One is it can automatically convert web services SOAP APIs into a very modern JSON format. Developers in the audience, if you look down as he's zoomed in, the left side is the WSDL format that the web service told him, and that's a very 2000 looking format. The right side is this RESTful JSON that was automatically created. He didn't have to do anything. He just pointed Apigee at the web service, and he gets a RESTful equivalent. Now, Apigee is a lot more than just API translation. If you see those badges up at the top, we also have a quota turned on, because this application probably can't handle a massive number of simultaneous web requests. So Martin has decided to put a quota on it to limit the rate that the APIs are called. He's also put authorization on it, because if we're going to have mobile apps talking, we probably want to control what mobile apps and what users are actually able to do something with it. Now, there's a lot more Apigee features for enterprise API management, but for now, we'll call it good that we've converted the API and we've put a quota and authorization. So, we got our images sitting in a GCS bucket. We've got our nice friendly API. How do we connect the two? Well, I could stand up a VM or a bunch of VMs, but like that's really overkill, right? All I want to do is when a new file is added to the bucket, I want to send it to this application. It's a perfect example of the sort of glue code that makes up most modern cloud-based applications. It's perfect for serverless environments like Cloud Functions. With Cloud Functions, I don't deploy an entire VM. This code here, this JavaScript, is the entire code that actually gets deployed. It's listening on that GCS bucket so that anytime a change is made, this function gets invoked, and you'll see what he's doing there is he's actually invoking that nice RESTful web service that we just got created. So great, with that, everything should be tied together. Let's see if the app actually can make an update all the way back into the legacy application. So we don't have a car crash on stage, so Martin, what do you got for us?
Well, I've got professional simulation equipment here.
This is our version of scaled down. So, go ahead.
Oh, crash. And now let's assess the damage.
So let's switch to the phone. Yes, that's nice. We like seeing the car over there. Can we get the phone on the main screen? Yeah. There we go. So take the picture. Oh, I like that there's an agent there too. I didn't see that. Very nice. Okay, so that's uploaded. Now, to prove that it's uploaded, let's switch back to the legacy app. And because it's a legacy app, we have to hit F5 to refresh, because remember, it's 2000. And sure enough, there's both of the pictures that we just saw have been migrated all the way through. Now, yes, please. Now, the last thing is, remember, this is an on-prem application running, I was going to say in a data center, but it's probably running under someone's desk, truth be told. So, how do we fix that bug? Brian talked about the migration wizard, or the migration tool. Mark will start that up, and in about 45 minutes, this entire running server, its disk, its memory, everything, will be copied and live migrated into a cloud instance, ready for me to shut down my existing application and have a fully cloud-based application that benefits from all that amazing infrastructure that we've already heard about. So that's it, a complete set of tools for you to take your existing applications, not just lift and shift them, but lift, modernize, and improve them along the way. So with that, Mark and I will say thanks, and we'll turn it back over to Brian.
Great, thanks Greg, thanks Mark. And I want to thank you for your time this morning. Hopefully I get a chance to talk to at least some of you over the next 2 days.
You're on Google, and you're enjoying the collaboration products, mail, calendar, contacts. However, you also have this need for business process to be automated.
Our agency, they don't have the money to do a full-fledged app. They just need something simple that makes their life easier. Right now we have the blue form because it's a blue sheet of paper.
The Wyoming Flexible Benefits Enrollment Plan?
You're filling it out and signing it, and then they have to data entry all that back in. 10,000 people, a lot of blue trees.
We were able to make this an app maker.
We showed it to our HR department, and they were so excited.
Honestly, at first I was very skeptical. It just seemed too easy. Like, oh yeah, I drag and drop a couple little things. What do I care? I'm a real developer. I don't use these little gadgets. But as I got to use the tool more, I was like, ideation all the way through the final delivered app to our administrators for them to use was 5 weeks. And that's just unheard of in any other kind of product lifecycle.
Why AppMaker? Because not everyone is me. I really like working deep down in the code, working low level. The great thing about AppMaker is you don't need to have that deep down knowledge. People are able to make these really snazzy looking applications that can be used by an entire company.
I never pictured myself developing anything. AppMaker is an insanely awesome way to solve a small problem.
AppMaker makes my job easier because I don't need multiple tools. I can just develop it directly on AppMaker.
One word to describe AppMaker: simple.
Quick. Flexible.
Versatile.
Empowering.
One word to describe AppMaker: game changer.
Hello World, but I'm going to make a slightly different version. So instead of Hello World, we're going to internationalize it, and it's going to be Hola World. And we're basically going to have it be able to translate Hello World into any language. So you can see some of the parameters you can select. For example, how much memory. So I'll choose 256. So you can write to disk in Cloud Functions under /temp directory, but it's basically an in-memory disk. So if you have 256 megs of memory allocated to your function, that's also your scratch disk space, so something to be aware of. And similarly, the more RAM you give it, the higher CPU you get. So if you really need high performance, you give it a high RAM count, and your functions will run more quickly. You can set the timeout. Currently, the maximum is 9 minutes. And say I want to trigger it via HTTP, and you can see it already gives me a URL fully qualified. So I'm going to make this a little bigger. I'm going to do the probably bad idea of live coding in this little text box. So I'm going to require the Google Translate package. So I'm going to say translate equals require Google Cloud. So this is the Node.js NPM module that /translate. That wraps the translation API. So one thing I want to point out is I'm requiring this, make this a little bigger, I'm requiring this package, and I'm passing nothing in the constructor. So if you had specific credentials, that's where you pass it in. But one of the cool things about Cloud Functions is you're automatically authenticated with default credentials to all of your APIs and all of your other cloud resources. So it makes it really easy to basically deploy your function, and it can automatically talk to the rest of your cloud project. If you do want to specify a certain account that maybe has a certain permission level, you can do that as well. So instead of hello world, I'm going to say hola world. And here we have a request and a response object. So if you've done any Express code in Node.js, this will be familiar to you, or really just sort of any web development in general. So the request is what's coming in from the user. So this could be the result of like a browser post, or maybe you're posting like some JSON to your HTTP endpoint. And then response is what you send back to the user. So here you can see in the example, I'm going to send status code 200, which means OK, and then some kind of message. This all looks like error checking, so I'm going to get rid of this nonsense because we don't do that here. And I'm going to say let language equals request.query.lang, or default to Spanish otherwise. So one thing Cloud Functions does also do is it automatically parses those incoming requests and makes it available to you in certain request properties automatically. So anything that's in the query string, you'll be able to access in request.query. You can also do request.body.whatever. So if there's a JSON payload in your HTTP post, we'll automatically parse that for you and make it available to you. So it's really nice. And now I'll call translate.translate hello world, and give it the lang, and here's my callback. This editor is needs some improvement. All right, so now I will respond to the user .status 200, and I'm going to send the translation. Okay. So one more thing we need to do is I required this Google Cloud Translate package, and the way you specify dependencies, both in Node.js and in Cloud Functions specifically, is through this package.json file. So it looks something like this. So dependencies, and here's my package. And then just whatever the latest version is. Now let me scroll down. So you choose where to deploy your source code. So it basically bundles up your code into a zip file, and it puts it into a cloud storage bucket somewhere. So this is where you tell it where that is, and then let me call my function hola world. This is the function within my JavaScript code that I want to run as a part of this. So let me create that. And sometimes it takes a second. So while it's doing that, let me just talk a little bit about the Cloud Functions deployment process. You can either do it through the browser, like I just did, or you can deploy from the command line. So this is really nice because we also have a local emulator. So you can write your function in your tools that you're normally familiar with. So if you're using like IntelliJ or Visual Studio Code, you can actually, in the local emulator, you can set breakpoints and step through it. Make sure your code is working on your local workstation, and then deploy it out to the cloud. So it's just your normal development workflow that you probably we'd be doing for any web app. So it's really nice. You also can use the API if you want to like automate deployment, things like that. And just talk a little bit about what you get. So I just wrote a handful of lines of code, and what Cloud Functions gave for me automatically an HTTPS endpoint with an SSL cert and a fully qualified domain. So this is really nice because I don't have to do any like configuration or create any manifest files or do any URL routing. Like Cloud Functions automatically did that for me. So it's really, really easy. There was no like pre-configuration that I did for that function. So I automatically get all of that. So I talked a little bit about the request and response objects, and you can see it's just super easy. Set status code 200 and then send howdy serverless fans back to the user. All right, let's see if our function deployed, and it appears that it has. So it has this invocations per second, so you can see, so this is, I guess, when I just deployed it. So you can see, so it does like a health check when it first deploys your function. It doesn't actually execute your function because your function is probably doing something, but it basically stands up the instance, makes sure that all your code, like all your includes work and things like that. And then if it doesn't, then it'll roll back so that you don't deploy a broken function, basically. So it should give me, here we go, a trigger. So here's the URL, so let me open this, copy this, and we should see defaults to Spanish, so there we go, hola mundo. I'm gonna get a query string parameter, I'm gonna say lang equals French, Bonjour le monde, Japanese, whoops, Japanese, what else? And German. So we just made an internationalized HTTP endpoint that will translate hello world. So pretty cool. I want to be able to say, whenever I change this value here, title, I want to say, howdy, London. I want that to show up in my, as my title of my page, right? Pretty straightforward. So here's my code. So this app.js is my client code. So again, oops, let me make this a little bigger. You're not writing any server-side code at all to do this. In a way, it's more serverless than serverless because you don't even write server code at all. You just interact with the Firebase SDK. So how that works is I'm going to get a reference here, so db.child, so title. So that is you can think about it like this, going to the root title. That is going to point to this location in the database. Let me make this a little bit bigger. See that? So now I'm going to say when the value changes, run some function. So snapshot. And snapshot is basically a Firebase wrapper around the value. So now I'm going to get the ID of that title here, so H3 page title, and get a reference to it. And then set inner text equals snapshot.val. So snapshot.val will represent whatever it is that I have typed here in the database. So in this case, howdy London. All right, so that's it. So let's see how that works. And let's actually change this a little bit. Let's bring in some other clients. So in the bottom left here, I have Opera. Remember Opera? Oh, still around, more or less. And then back here, lurking, I've got Firefox. Come here, there we go. So this is all happening on my, all these browsers are on my local workstation, but this is all happening over the public internet, which means you could think of these clients as being on your phone or on your desktop anywhere in the world. All right, so let me do a little refresh. And you can see that immediately they all change to, this one doesn't change. Oh, caching, my mortal enemy. Let's try this one more time. Empty cache and hard reload. Yes, there we go, howdy London. Pretty cool. And if you want to see the real-time nature, let me do something else. I could say like, oh my, OMG, real time is so cool. That's not really how I talk, I'm sorry. I don't know why I typed that. But if I hit enter, then they all change almost instantaneously. And again, that's happening over the public internet. So these clients could be anywhere. Mobile, they could be native iOS or Android. Super, super cool. And so that's Firebase real-time database. And what we added 6 weeks ago was integration with Firebase and Cloud Functions. So now one of the triggers you can have for your Cloud Function is a change in the Firebase database. This is super, super cool, because Firebase, you end up writing a lot of code on the client, but some things you just can't do. Language translation, for example, you probably wouldn't want to do on the client. Image analysis, you wouldn't want to do on the client. Now, you could call out to the Google Translation API, you could call out to the Google Vision API from the client, but now you have to somehow get credentials to the client to call that API, and you sure as heck don't want to give your cloud credentials to this random person on the internet, so you have to create some service account, and it starts to get messy. It's way easier to just have some function that runs whenever a value is triggered, is changed in the Firebase database. And I won't walk through live coding that, but it might look something like this. So if I delete this, so I've created this function ahead of time, but now I'm going to say title 2. I'm going to say hello, serverless, friends and enemies, and hit enter. So immediately it updates that, and then if we wait a second, it should trigger a Cloud Function. Boom, and it translates all of those to hola amigos, sin servidor y enemigos. No idea if that serverless translates right, but that's what it is. So that is really, really cool, and that is brand new as of only a few weeks ago. So that's Cloud Functions for Firebase. All right, I'm just going to briefly touch on a couple of other things that Firebase does. Cloud messaging, similar to the real-time database, but the real-time database only works when the user is on your page or is using your app. So if they've closed your app, or they've closed your browser, or they've minimized your browser, the real-time database doesn't work. So you can use cloud messaging for one of two things. One, either to send an actual notification, like on a phone, you know, the thing that comes down from the top and you swipe it away and it's super annoying. You can do that. or you can use it to send data to your application in the background. So in the case of like a website, there's a service worker that can be running offline, and it can be updating some local browser data store, some local browser cache. So the next time the user opens your app, that data has already been, the web app, that data has already been updated locally. So super, super cool. And another thing that if you think about how you might do that traditionally is really complicated to do in a server full world. So you have to have infrastructure to manage all these device tokens from all these devices. You have to have something to manage all the subscriptions, because maybe users want to get notifications about certain topics but not about others. So you have to manage all that data. And you have to manage the infrastructure of, I know this device wants this kind of notification, but he's offline, he's in the subway tunnel. I'll wait a minute, okay, she's back out of the subway tunnel, let's try again, I didn't go through, okay, we'll try it again later, right? So that's a lot of stuff to keep track of all those devices, their online state, their offline state. Firebase does that all for you, so super, super useful. And then authentication. So Firebase has built-in auth, so you can basically get a sign-in UI out of the box for Google, of course, GitHub, Twitter, Facebook, email and password. It manages all that for you. And if you have an existing system, you can write a custom integration to do auth to your existing system if you have something custom. So it's really, really easy. And if you use any of these providers, Firebase can also handle all the annoying stuff, like user needs to reset the password, things like that. It also supports anonymous authentication, which is pretty cool, because basically the user comes to your app, and they just get assigned a login, right? And then later you can associate that with their account. But the idea is they can navigate your site, and they can be customizing it. So think about in an e-commerce application. User comes to your site, obviously you immediately want to let them start adding things to their cart without making them sign up for an account. Get them hooked, get them engaged in making that purchase, get them excited about thinking about it. And once they're excited about buying it, then the overhead of signing in with Facebook, Google, or Twitter. But the anonymous authentication, you can give them right away and associate that user ID with them. So very, very cool. And that's the last thing about Firebase that I'm going to talk about, other than I mentioned the database triggers being new. So anytime you can watch any value in the Firebase database, and anytime that changes, you can run some little function serverlessly in the cloud. We scale for you. Very, very cool. Firebase authentication. User checks out of their application or in their shopping cart, or user takes a survey, things like that. Well, that conversion event can also trigger a Firebase function. So you need to do some kind of fraud detection or whatever you might need to do. Maybe send them a thank you email if they took the survey. Whenever that conversion event happens, you can just serverlessly run this little snippet of code in the cloud. No infrastructure required, no management. So very, very cool. So we talked about a few things. We talked about platform as a service versus functions as a service. So it's App Engine versus Google Cloud Functions. We talked about, and we will talk about Firebase versus Cloud Data Store. And then I'll also talk about should you be positive or how negative you are. So let's do a couple of quick queries to see what we're running here. Oops. Make this a little bit bigger. So right now 31 positive messages, 2 negative, so that's pretty cool. What else do we have? Most people are generally feeling good about life. Ooh, let's see if anyone has sent any emojis. All right, 1 sunglasses face and 1 applause hands. That's pretty cool. So to kind of illustrate in a little bit more detail why and how this is interesting as being serverless, I'm actually parsing a JSON payload that's in the table. So I don't have the schema here, but it's taking directly the output of the natural language API, which is like this complex JSON blob. And in my query, I'm parsing that for every record, every time. So it's maybe not that crazy to do that over 40 whatever text messages, but if you're doing this over terabytes and petabytes of data serverlessly, this is really, really cool to be able to do on-the-fly text munging, text analysis, JSON parsing to really get into and monitor your data. So let's see, is this all right? Now we've got a whole bunch of texts coming in. Serverless, hello, birthday, awesome, cool. All right, thank you very much for doing that. And just to drive home
has been put to use digitizing paper content for enterprise content management systems like Platinum IDS. It's been used by realtors to streamline the home buying experience. It's been used by social media companies to identify inappropriate content. And we recently announced new functionality for our Vision API to support many use cases for image understanding. First is an expansion of the API's metadata that recognizes millions of entities from Google's knowledge graph. So now you're able to use the same metadata that powers Google image search for your application. This enables customers to derive image metadata that can span from news events to popular products present on the web, or to determine if an uploaded image already matches another image that's already available on the web. In addition to that, we've also enhanced our optical character recognition so that you can retrieve text from text-heavy images, such as legal contracts, research papers, invoices, and other complex documents. And both features are available in beta today. But the world of pixels goes way beyond just pictures. In fact, the most prevalent data on the internet is video. Hundreds of terabytes of digital video are being generated every hour. And understanding the contents of that data has tremendous commercial value. And today I'm very excited to share with you a new API that we recently announced, the Video Intelligence API. This API is the first of its kind. It enables developers to easily search their videos for entities that are inside those videos. For example, you can search your video for nouns such as playing or building, or for verbs such as running. In fact, not only do we identify the entities inside of those videos, we provide contextual understanding of where those identities appear in the video. So if you search your video for something like robot assembly line, you'd get a result showing all the shots for automated assembly lines in your video library. Now I'd like to introduce Dave Starling, CTO of CNET, and Greg Michelli, who will demonstrate this API in practice.
Thanks again, everybody. We thought to show you the Video Intelligence API, instead of using some of Google content, we work with a great customer partner like Dave at CNET and show you with some really fascinating content and the value the customers are getting out of it. So, Dave, why don't you give us a little bit about CNET and who you are and how your relationship is to video?
Sure. Good morning, everyone. So, CNET is helping power some of the world's largest organizations to reimagine the way they use video, create story-driven video at scale that is both trustworthy and impactful. And we're working with Google to power all of that technology, and we've been really pleased to be able to input into the machine learning API and power all of that technology that powers our customers. So we have a huge range of clients with enterprises like Rolls-Royce, Unilever, and HSBC. We're powering employee transformation programs, giving voices to hundreds of thousands of employees across the globe. With retailers like Clinique and The Body Shop and Benefit, we're putting the power of brand advertising directly into the hands of the consumer. And with broadcasters like the BBC, NBC Universal, and BT Sport, we're helping fans and TV show fans get closer to the teams they support and the shows that they love by making them an integral part of the broadcast show.
So, and I understand, you mentioned BBC, and I understand you've got a demo over there of using some of BBC's Nature's amazing video content and how the Video Intelligence API lets you work with that. So why don't we go over and show us that?
So the BBC uses CNET to collect footage and content from all of their nature documentary folks, and then also from their community. They have a huge amount of community content in there. So, here we have their studio, and we can make a search now for content that's been automatically tagged. So let's search for a frog. And we get all of this amazing content come up. The network gods.
Will they smile on us?
There we go. So now we have all of this content that's been automatically tagged by the Google Vision and Video APIs. So that nobody had to go through and manually tag all of this content. It's in there, it's searchable within seconds. And it also means that people don't have to imagine the type of content that they're going to have to manage in the future. Right. So you can search then for more abstract terms. So, what describes a scene? So let's go for a sunset. So here we have loads of content that's been automatically tagged with sunset, and some of them are obviously sunsets, and some of them are beautiful, and you get additional tags like clouds. But we can also then look at visualizations of the data set across all of that. So if we go into a specific project, here we have jungles. All of this content has been tagged, so we can look at basically a tag cloud of all of that content. Tens of thousands of pieces of data, all in here, ready to visualize.
That's a great example of how you find the needle in the haystacks of data. For example, I looked at this and I would have never thought New World Monkey? Like, what the heck's a New World Monkey?
Well, let's find out. If we click on this, we get this funny little guy.
And if there's any biologists in the audience, somebody can probably verify that that is in fact a New World Monkey.
Yeah, and it's very good at those sorts of species recognition. So yeah, the BBC have been super happy with all of that.
That's awesome. Now, yesterday we asked you in the audience to use the mobile app to do your own video uploads. So I think you've been working over the night with the Video Intelligence API and the other machine learning APIs to give us a sense of what the collective group took videos on. Can you show us that?
Yeah, absolutely. So firstly, thank you to everybody who took part. We had 160 people sign up. I think about 60 people contributed at least one piece of content, and we got about 250 individual pieces of content, which came up to about 2 hours worth of footage. So here we can see some of it here. So back in December, we've been part of the Trusted Tester Partnership with Google for a long time now. We did it with speech and natural language, and then back in December, our account manager called up and said, "Hey Dave, we've got this new Video Intelligence API. That sounds like something that you'd be interested in." And so I was cool about it, and I said yes, but inside I was like, yes, this is quite exciting.
And what candy store?
Exactly, and what that gave us is the ability then to drill down into a much more granular level, to the frame level, to say, okay, we've got 2 hours worth of footage. How does a content producer find the right 2 seconds that they need? How does the editor find the bit where someone is walking and panning, or talking and smiling? So let's have a look at the similar set of data that we got for the content yesterday. So unsurprisingly, a lot of people were recording the presentation. So the top one is presentation, but it's a really interesting one here. So we have convention, display devices, academic conference because you're all learning, I'm sure. Even the way people are feeling, so happy and joyful, people smiling and so on. But we took it a little bit further than that as well. So when we integrated the speech API, we were able to see what people were talking about, what were the key words, and how were people describing what they were doing at the event. So similar kind of visualization here, running through the speech API and then pulling out what people are talking about. Unsurprisingly, people were talking about Google.
Well, that's a good sign.
So you're all on brand, you're doing well. But there were, people were finding it interesting, looking forward to tomorrow, naturally, because that was still yesterday and they were looking forward to this. Great, further, everything, customers, all really exciting. And so that was the second way of handling all of this data. The next way was then, let's take all of those transcriptions and feed them through the natural language API. So we can then actually say, okay, if people are talking about Google, were they talking positively about Google?
Now, I have not seen the results of this, so talk about a live demo.
So one would assume so. But also, as a brand or someone who wants to derive insight from their employees, this is really powerful because it means that they can then pull that content and find where people are happy and unhappy. And actually, all of this then becomes greater than the sum of its parts, because we can take all of that content and say, right, are people being genuine? Is someone smiling, but actually what they're saying is very negative? And also, we can then take all of this data and then feed it into our own machine learning models. So if we know that where content is being distributed, we can see what type of content works well, and is there a better way to engage with those specific types of people?
That's fascinating. That's awesome.
So I think we'll wrap this up with the edit that we did yesterday. So this was all powered by you guys and the machine learning API. So 2 hours worth of footage. How does an editor get that down into 60 seconds effectively? Let's see what the results are like.
So here we are at Next London.
Good morning everyone. Cloud Holston, here excited to see what Google Next has to offer.
Cloud's infinite, possibilities are infinite, growth capabilities, your business on the cloud.
Google Cloud is about customers. We will prove them and help them understand the right components.
Seen it for around 3 years, and we've been a Google customer since day one. How we're really doing something fundamentally different.
When you add the power of the cloud, that really allows us to educate your people.
The devices are secure by default. Your tablet, your Android phone.
Hi, I'm Maleka Aslina. I'm George.
That's awesome. And with that, we'll turn it back over to Brad. Of meetings, of collaboration, way beyond where it is stuck today. And rather than my talk about it, I'm going to welcome on stage my colleagues, Serge, Priscilla, Lucy, and TJ, to give you a bunch of demos so you can see where this is going. Come on up, team. Hi everyone, my name is Serge. I'm a product manager from our Stockholm office, and our team in Stockholm has built a lot of what I'm going to demo to you today. And today, I'm going to talk to all of you about how we've rebuilt Hangouts with a focus on team productivity. To show you this, we're going to go visit a company called Cloudy Coffee. They invented coffee that's 100 times stronger than normal. And I wish that stuff really existed, because I would have taken a big cup of it this morning. Cloudy uses the new Hangouts chat. It's an intelligent messaging app built for teams and deeply integrated with G Suite. Cloudy already uses Hangouts for their instant messaging needs, but they now have access to Rooms. So Rooms are a central place where team and project conversations can occur. And so, instead of me just talking about it, my colleague Priscilla and I are going to go and demo this for you today.
Great, thanks Serge. And good morning, Next London. I'm super excited to be here today, walking you through this demo with Serge. So let's get this rolling. So to get started, you'll soon be able to see my screen. And let me just get you oriented a little bit. On the left-hand side, you can see a list of all the rooms where I've been having chats with colleagues or teammates during the day. If I click on one, it takes me into this room, where then on the right-hand side of the screen, you see that our conversations are threaded. And what that allows us to do is have, in this conversation, a passionate debate about whether we should have pizza or sushi for lunch, but then neatly segmented is a separate conversation where we're actually doing substantive work. Now, there's two things I want to point out about this right now. The first is that we are deeply integrated between Docs and Drive and Hangout. So what that means is it's super simple to embed documents. With one click, you're taken into the document, and you're able to access it just like you would any other kind of Google Doc, with G Suite online collaboration. However, the best part about this is that the access permissions are totally taken care of. I don't have to spend a moment of my time thinking about whether Tom or John or Lucy has access to the document. If they're in the room, they have access to that document. The other thing I want to highlight right now is that we've also built this with a very powerful search functionality. With a simple click, I'm able to search and filter by a user and file type. So for example, if I know that Patrick embedded a slide earlier in the day, I just click on Patrick, and then I click on Slide, and sure enough, it quickly takes me to the slide presentation which he embedded earlier today. One click, and I'm in.
Wow, thanks Priscilla. Let's move to the Cloudy launch coordination room, because we need to coordinate this launch of a new coffee type.
Sure.
Great. So today teams work with a myriad of tools. And it was only natural that we've built Hangouts Chat with the ability to do deep third-party integrations. The integration capabilities we've built go from simple Google App scripts that you can integrate into your team rooms, all the way to intelligent bots. Let's take a look at an example of that. Let's say that Cloudy Coffee uses a third-party project planning tool called Asana. It helps them understand who's doing what. The Asana bot is this. I still can't comprehend how hard it can be to create meetings, to have people join them online. It just makes no sense to me. And when we embarked on recreating a new meeting experience, this is something we really put all of our focus on. How do we remove that friction? How do we get people effortlessly into meetings and talking and working together and getting things done? In this meeting experience, this translated into, let's not have plugins to download and install. Let's have software that we need to download and install. Let's make sure that you don't need an account or remembering a password to get into a meeting. It also means that we've focused on making the whole experience a lot snappier. Make sure that you're in full control of what's happening, and when you click and when people talk, things happen quickly and instantly. So we've done this by reducing the code size of the meeting experience. And doing that led to great advantages. It meant better audio and video quality. It also translated into much quieter CPU fans. So, all right, I went on a little bit of a rant there. Let's go into the meeting experience and show everyone what this is all about.
Sure, and rants are great. Passionate product managers make awesome products. All right, so taking you back to the demo, you'll remember we have this URL that is going to take us into the meeting. I do one click, and I'm taken to what we call the green room. And it gives me a chance to say, adjust the camera, see that my hair is a mess. I can also make sure I have my notes, catch my breath, collect my thoughts, and then with one more click, I join the meeting. Hey, team. Welcome to Next London. Hi. I can see that you're in Stockholm. Now,
they really are, I promise.
They really are. So audience, this is actually the team that built this product that you're seeing demo. So can we give them a warm welcome?
So what you're seeing here is a new Hangouts Meet. It's available to all of our G Suite customers today. And did you see how quickly it started? The machine right there is a 2-year-old Chromebook. It's my own personal machine. It's banged up, it's scratched up, and still on a 2-year-old Chromebook, boom, you can have a great audio and video experience just like that. We joined this meeting through a chat room, but these meetings can also obviously be created and put into Calendar. A shared link can be shared, or you can access them from our dedicated mobile apps that we've also recently launched. So it performs well, it has good audio and video quality, but what about those friction moments? So if we go back to Cloudy Coffee, launching that strong Hangout can see what's going on.
Stockholm team, are you in our jam now?
Yep.
Yeah. Great, let's get started.
Great. We have an opinion of the stylus. The Jamboard stylus is passive. What that means is you don't have to charge it, you don't have to pair it, you don't have to dock it. It's simple, it's intuitive, and it doesn't cost you an arm or a leg if you lose it. More importantly, the Jamboard recognizes the difference between the stylus and my finger. So I can actually start writing with my stylus. And erasing with my finger. It's as simple as that.
So let's get started on some brainstorming for this ad campaign. But TJ won't be working alone. We also have team members joining from the Jamboard Companion app. Whether they're in the same room or working remotely, they're able to collaborate with us in real time. The Companion app is available for both Android and iOS devices. So now, whether your team is in the same room, in the same meeting, or even just in the same jam, we're all able to virtually stand up at the whiteboard and add our ideas, or make a point, or even just move around content that's there already. This is the same magical, collaborative editing experience you're used to with Google Docs. So now that we're all at the whiteboard, who's working with us? Well, we have Gotham from Greenland, obviously our Stockholm team up there, and also Corinne from Brazil, or maybe even the audience just over to my left. We're all able to work together in this meeting in real time. So back to our ad campaign, I see there's some good ideas up there. Where are we targeting though? Where should we have our billboard located?
So I'm going to do a web search here. I'm not sure if the cameras can pick it up here, but you might be able to see the board better. So I'm going to do a search for London.
Yeah, let's go big. So this is the power of web, the power of Google. TJ's able to search and bring up functional, relevant, beautiful content to really bring our jam to life. So as you can see, we have our web and maps tool here. Let's also have a think about some of the visuals. What's kind of the branding or the look and feel of the campaign?
So I'm also going to do an image search, and I'm going to look for images that represent our coffee brand. And just like that, I get results on the board that I can just simply drag over. And you can also see here, our collaborators are collaborating with me, and they're able to add content from their mobile devices or other Jamboards.
That is looking awesome. Jamboard is also integrated with Google Drive. This means that your team can now bring in content from a presentation, a spreadsheet, or a document that we can all work on together in a meeting. Great, well this is really coming together. I think we're nearly ready to send across to the ad agency, but TJ, I was looking up on some of the frames here, and your handwriting is really hard to read. I mean, I don't think they'll be able to read it either. Lucky for us, Jamboard makes even the most hard-to-read handwriting legible. TJ, you want to fix that up?
Real quick, I'm going to use our handwriting tool. And we'll see the magic happen. So what you've just seen here is the power of machine learning that helps recognize my awful handwriting and just makes it awesome. And when you're done, just close it. You don't have to take a picture of your whiteboard anymore. A picture that your
application logic to the client. And there's a really nice upside to that. By not writing any server-side code, you're actually really focused on the user experience, whether that's on Android, iOS, or the web. So as you're developing your app, you're spending all of your development cycles in the client, thinking about how the user interacts with your application and giving them a really nice experience. But because all of your application logic lives on the client, it introduces some complexities when you want to do certain things. So for example, if you want to send a notification, like a push notification to your mobile device, or an offline browser notification on your browser, that's really difficult to do if all of your code is on the client. You actually can't do it client side. Say you upload a file, a photo through Firebase Cloud Storage, and then you want to resize it, you want to create some thumbnail version. Well, you can't really do that on the client either. Filtering offensive language, maybe send notifications to users to re-engage them, create an HTTP endpoint. So these are all things that you can't do on the client side. It's been really so for example, if you're uploading an image to create thumbnails, for example, Firebase gives you some nice features that you will lose. So you could create your App Engine instance, you could create your thumbnail, you could have it respond, so the app could upload the image to your App Engine creates a thumbnail, and then maybe writes it to cloud storage. So that's nice, but if you use the Firebase SDK, there's a lot of benefits that you lose by doing this. So for example, Firebase SDK automatically handles resumable uploads. So if a user is starting to upload a file and they go offline, I live in New York, so if I go in the subway and I lose connectivity, the App Engine instance, the connection would just terminate, the user would get an error, they would get connectivity again, Maybe you retry it on the client, maybe it fails again. Well, resumable uploads is nice because you can basically pause it. Once you get connectivity, continue where you left off. So that's really, really powerful, and it's a huge pain to have to write on your own. So if you created your own custom backend, you would lose that feature of Firebase. Resumable downloads, so similarly to resumable uploads, the user's downloading a file and lose connectivity. If you're writing it yourself, you have to handle all that logic yourself, whereas the Firebase SDK takes care of it for you. End user auth, has anyone done like OAuth 2 authentication? It's horrible. I see a lot of sad faces in the crowd. Firebase does that for you, and so you would actually have to wrap all of your API calls in App Engine or whatever your custom backend is. You would have to do all the authentications for you, whereas if you use the Firebase SDK, it's all done for you out of the box. Pay as you go, so if you have some server up in the cloud, it's just running all the time, whether or not users are interacting with it or not, and that can add up pretty quickly. So those are the things. Oops. Oh, and then global scale. So maybe you just have that one App Engine instance or one virtual machine, and if that goes down, then you're really in trouble. So these are some of the challenges that users have faced when they try to do some things in sort of on the server side when they're building a Firebase application. Luckily, we can do all of this. Our developer here is super happy. He's throwing confetti in the air because we now, as of 6 weeks ago, have introduced Cloud Functions for Firebase. So all that cool serverless Cloud Function stuff I just talked about in the beginning can now get triggered via Firebase actions. So you can have these serverless server-side code that runs serverlessly. How many times can I say server? And you get all those nice benefits like pay as you go, so you don't have to have this persistent compute instance that's just running all the time. So Cloud Functions is a great way to run your backend code without having to manage any servers. It really is just a few JavaScript files in your project that you deploy out, and we take care of all the scaling and routing and load balancing, scaling up, scaling down. So we're really, really excited about that. So it's also a great way to integrate the Google Cloud Platform with Firebase, because once you're in a Google Cloud function that's been triggered by Firebase, you have access to the whole world, depending on your IAM permissions, the whole world of your Google project. So you can do anything from create virtual machines to interact with machine learning APIs to interact with Google BigQuery. It's a really nice sort of entry point from Firebase rather, into Google Cloud Platform. So these two things go really, really well together. They go together sort of like peanut butter and jelly. But someone told me yesterday that y'all don't really do peanut butter and jelly in the UK, so I don't know what like a good analogy of two things that go together, like tea and scones, does that work? Sure, can I use that? Is that offensive? So tea and scones. So I didn't have a chance to update the slides, but imagine one of these is Firebase, is the tea, and scones is Google Cloud. There's probably some weird analogy there that I don't really want to make, but it's a really nice way to integrate. And the way I'm going to show this off is I'm actually going to build an application that does exactly what you see on the screen here. I'm going to give it two terms, tea, scones. It'll go out to the internet, pull an image of tea, pull an image of scones, stitch them together, overlay this heart, and save the new image out to cloud storage. And we'll walk through building that application as a way to hopefully show you how you can really easily use Firebase and Cloud Functions to build an application. So we'll start how you might traditionally start to build an application like this. I'm going to sit here at my laptop, write some code. I'm going to deploy this code out to, say, a function as a service, maybe something like Google Cloud Functions. And then that's going to get exposed as an API over HTTP. So my browser or my mobile app can consume this HTTP endpoint, say submit a query with submit a request with two query parameters like term 1 and term 2, so tea and scones, peanut butter and jelly. The API will take those two images, stitch it together, save it to cloud storage, and return the URL. So let's start building that. So Firebase functions, the Cloud Functions for Firebase, all of your functions live in an index.js file. If you've done Cloud Functions before without Firebase, you'll notice there's some slight differences in the way it's structured. Cloud Functions without Firebase, you deploy the functions one at a time. If you're using Firebase and the Firebase SDK, they all go in your index.js. Secondly, you get this NPM module called functions. So Firebase functions pulls in it basically wraps a lot of the Firebase events so that you can respond to them in your Google Cloud Function. So let me also add in a couple of other imports here. So I'm going to require the Firebase admin SDK. So this basically lets me access the Firebase database as an administrator. Since I'm running in the server, we can feel comfortable with that because normally we wouldn't want to give, again, since your code is usually running on the client in Firebase, you don't want to give the client administrator access to your Firebase database, but you can, and when I say admin, you can set specific permissions. It doesn't have to be like global admin, right? You can say it's still some specified user, but it's not the end user. It's your sort of service account in the cloud, and you can set permissions to that. And I'm just going to call initialize app, has a reference to the database I'm going to use, and then also this is the service account that I'm going to connect with, credential with, in my Firebase application. So now I'm going to create an HTTP endpoint. If you've seen vanilla Cloud Functions without Firebase, you know it functions. So what that only functions is, Firebase deploys all of your Firebase project basically, but you can say, for example, don't deploy anything except the functions, and I'll talk a little bit about what some of the other things you can deploy with Firebase are. But in this case, we're just deploying our HTTP function and our Firebase function. So again, it's going to deploy everything that's in this index.js file, which right now is just one function. So, oops. Well, while I'm on the slide, I'll talk about it. So we're going to trigger an HTTP function, but there are 6 events that will trigger your Cloud Functions for Firebase. Cloud Storage event, which is the one we'll look at next. Cloud PubSub, HTTPS, which is the one we're just deploying. The Firebase real-time database. So you can watch locations in your Firebase database, and when certain values change, a trigger can automatically get changed. And that's where you can do something like look at the message and see if there's offensive language, and if so, filter it. Maybe you want to do some data validation and see, did they put in a weird value, and if they did, like kick it out, or don't put it into another location in the database. Authentication, and then Firebase Analytics. So these are new as of a couple of weeks ago when we integrated Firebase and Google Cloud Functions. All right, so our deploy is done, and you can see it gives us this endpoint, and it's an HTTP endpoint. So let me curl that. And so I'm going to give term 1 Batman and term 2 equals Robin. Awesome. What am I missing here? Curl. Is that right? Not found. So far, so good. Oh no. Huh. Let me just. Oh, thank you. Thank you. This is the world's biggest pair programming exercise. I had an ampersand instead of a question mark. Now we should see this. So it may take a second because again, it's fetching some images from the internet, pulling them down to the Cloud Function, and then outputting. So what this is a assigned limited time URL. So in cloud storage, you can expose your files publicly, and when you do that, you can actually set a time limit on it. You can say, give me a URL that someone can access, but only for 1 minute, or 1 day, or 1 week, or whatever. So it's a really nice way to kind of expose your files out on the internet, but preemptively sort of secure them without you having to do anything. So let's look at this image, this Batman and Robin image that I just created. So not quite the Batman and Robin that I was expecting, but you know, search is hard. But that's cool. So we've begun our journey to world peace, where we're going to start to combine all these crazy disparate concepts and bring a little harmony to the universe. So step 1, HTTP endpoint. So now what we want to do is we want to put this in our app. And I've built this little app. It's ugly because I'm not a UI designer, but basically you give it 2 terms, so you know, X and Y. You hit the button, it will call the endpoint that it just created, and then display the results to the user. So to do that, I'm going to switch out of index.js, which has my Cloud Functions server code, and I'm going to switch into app.js, which has my client-side code in the browser, the demo app that I just showed you. So I put a little bit of a skeleton here already. I've wired up a click listener to that heart button. So the first thing I want to do is get the value of text box 1 and the value of text box 2. And then if I've supplied those values, now I'm going to make an AJAX request from the browser. So here we've got our XML HTTP request. And then here is the URL of the function I just wrote. And I'm going to very securely just append whatever you put in that text box. So be gentle. And once that's done, So on the onload, when the response comes back from the server, I'm going to call this add card. So this is a function I created ahead of time, so you know that I'm not like cheating too much. Here's add card. All it really does is, nobody wants to watch me live code this, creating HTML. But basically it takes a URL, creates a card, we'll call it, in Material Design, and then writes it back out to the browser. And then once that's done, I'm just going to reset my progress bar and reset my form. So let's take a look at that. Let me refresh. And if we want to watch the traffic, let me open up the console so we can see the network request. So I'm going to say tea and scones and hit that, and you should see that request go out. And if the demo gods are on our side, all right, there we go. So got a response, created the image in the cloud, and put it in the browser. Super, super cool. So that's great, but there's a couple of problems. One, if I refresh this, it goes away. So we need to add some kind of persistent store to our application. So that's where we'll use the Firebase database. And secondly, we were able to return in a relatively reasonable amount of time the URL to the image. But if we were doing something that was longer working, that maybe we just wanted to immediately tell the client via our API, like 200 good, got your request, but I don't have a response for you now. So check back later, right? So for that, you would tell the client, maybe here's some kind of token, you can check your status later via another endpoint. Well, that's a little tricky too, because either now you have to have the client constantly asking your API, hey, is the job done yet? Is the image created? Is it created? Or you do something like WebSockets. Well, WebSockets you can't do in a serverless function as a service environment because you need a server that's just up and running, maintaining a persistent connection to your client. So it has to be up all the time. And since functions as a service are designed to be very short-lived, to run for a bit and then die off, they're not a good fit. So you would have to go back, normally you'd have to go back to creating your own virtual machine, creating your own app engine, well, App Engine doesn't do WebSocket, creating your own virtual machine to do that WebSocket so you can push that notification down to the user. Luckily, the Firebase real-time database lets us do both, notify our client and give us persistent storage. So let's add that. So I'm going to go back to our index.js, and what I'm going to do is make a trigger off of cloud storage. So when you upload something via Firebase storage, it also goes into Google Cloud Storage. They're one and the same. If you look at it in the Firebase UI, you see the same files you see in the Google Cloud Platform console. So anything you upload to one or the other, it's seamless integration. They're the same storage bucket. But what I can do is trigger a function to run in the cloud whenever a file is uploaded. So what I'm going to do is when the API that I just created, it writes a file to cloud storage, I'm going to trigger a function to get the URL of that image, and then I'm going to write that to the real-time database. Does that make sense? So client calls the API generates an image, saves it to cloud storage, and it's done. But then there's a trigger on that cloud storage event to take that URL and save it to the Firebase database. So I'm going to go back to index.js. So again, this has our Firebase functions. This is our server-side code. And, oops. Wait, what is this? There we go. So I'm going to create a function called insert image URL. So you'll notice the function signature, functions.storage.object.unchange, is a similar sort of structure to functions.https, the onRequest. And then the cloud functions for Firebase all have a similar format. So functions, which is this npm module I included up there, dot service type essentially, and then the event specifically that you want to listen to. So whenever an object changes, then I want to call this function. So the next thing I'll do is create the value that I want to insert in the database. And the Firebase database is it's JSON based, it's NoSQL. So just any JSON that I want to put in there, I can. So I'm just going to put an object that literally just has one property. So one thing to know, this E event is going to be the same regardless of what type of event triggered you. And under the event is a property called data. And that's going to have some data that is specific to the type of event that just occurred. So because this is a file change event, data has a property called media link, and that points to the location in Google Cloud Storage. And that is what I'm going to push into the database. So now I'm going to use this admin that I talked about earlier. This gives us access to the Firebase database from the server rather than from the client. And I'm going to reference Harmony. So maybe it's easier to think of this as /Harmony. So root node /Harmony. And I'm going to push this JSON object that I just created, and then I have a callback, and I'm just going to return. So let's go ahead and deploy that. So again, Firebase deploy, only functions. So now we're uploading cloud to cloud storage. It's triggering this function. It's going to write the URL to the Firebase database. Now what we need to do is on the client side, we need to listen to that location in the database so that when something comes in, we can display it in the browser. So I'm going to switch out of the server-side cloud function code back to our client code. And now, after we make this API call, we're not going to actually add the response directly. We're going to wait until we see the event happen in cloud storage. So again, we're going to listen in the Firebase database. This is on the client. We're directly connecting to the Firebase database. We're going to listen to /harmony. And you can see the structure here, firebase.database. It looks very similar in the client versus on the server side in Cloud Functions, and that's intentional. And that's why Cloud Functions with Firebase and without Firebase look a little bit different when you declare them. It's just so something's more idiomatic to the Firebase SDK. So the Firebase SDK will fire on the client anytime a child is added to that node on the server. So this is something that's normally really difficult. Like I said, you have to have a push notification, a push mechanism in place, like WebSockets. And it's going to provide this snapshot that gives us the ability to access the data that we just added. JK. All right, so we're just going to get snapshot.val, which is going to represent the value in the database, and then we're going to call that same add card functionality that I put up earlier. All right, and our function is deployed. You can see it updated the image match since it was already in the file, and then it created this insert image URL. So now if we try this again, and let's try Batman and Joker maybe this time. Who knows what this is going to bring back. So it should make that request. And if I look over here in the in Firebase, something happened. If I go to functions, I can see the log. So let's take a look. And so it just called the insert image URL. So it may take a second. Let me pull up the database here. We should see it show up in the database. We should see it show up in the database. Oh, there it is. So it took a second, but there it is. And so as soon as it showed up in the Firebase database, it instantly showed up on our client browser. So pretty cool. So now if I refresh, it comes back. So we have persistent store and we have real-time syncing, which means that if I open another one and I search for tea and scones, they should update in both places simultaneously. And it's going a little slow today, so maybe I won't sit here and watch it, but hopefully in a second. That's fine, we'll come back to it. We don't have too much time left. So that was triggering off a storage event, right? So we created a file, uploaded the storage, and then that triggered a function to insert into the database. So we're going to actually chain on top of that. So we're going to trigger off the database change itself to send a notification to clients. So you know those little, like a browser notification that pops up, either on a mobile device or in a browser? We're actually going to send one of those whenever a new entry is put in the database. So we're basically creating this chain of events on different events. So Firebase database I talked about, does real-time synchronization. It's JSON, it's NoSQL, fully managed, so you don't have to do anything except just talk to the Firebase database using the Firebase SDK, as we just did. So now we're going to do what I just described, which is we're going to listen to changes here at /harmony, and whenever something happens, the URL that gets inserted into the database, that is going to trigger another function, and that's going to use Firebase Cloud Messaging to send messages. So Firebase Cloud Messaging it is also fully managed, it's fully serverless, you don't have to manage any of the infrastructure for delivering notifications to your users. And so this is actually not something that would normally be pretty difficult. So as your users are coming online, offline, their phone's off, they've minimized their browser, they've closed your page altogether, Firebase Cloud Messaging tracks all of that for you so that when it's appropriate to send the user the message, it will automatically do it. So let's take a look at that. So I'm going to go back to our cloud. Let's see if this, there we go, tea and scones. I knew it would eventually show up. Let's go back to our cloud messaging, our Firebase Cloud Functions file, index.js, and I have another to do here. I want to send notifications. So I'm going to create another function, and this function is going to listen to /harmony/push_id. So you can also have these sort of wildcard parameters when you're watching locations in the database and have access to that in your code. So I can actually access, for example, during d.params.push_id. So if I have some sequence of paths with these wildcard variables defined, I can actually, in my function, get the value of those. So it's really, really nice. I'm not going to use it in this particular case, but just so you know. And so whenever some value is written to the database, then I am going to first make sure that it's not a delete event, because that will also trigger. So if I have a value here, then I'm going to go get the device token. So the way Firebase Cloud Messaging works is your client device, whether it's your mobile device, mobile web, or your desktop web, it will request permission to send notifications. When that happens, an ID gets generated. So I'm going to show you how the ID gets generated in a second, but assuming now we have it in the database, we're going to go get a list of those IDs from the database, and we're going to send notifications to all of them. So in the Firebase database, I have a reference to /notifications, and this is the database location that will store all of our tokens. I'm going to call once, which is the Firebase method to just get the value as it stands. So normally in Firebase, it's sort of actively listening to the database, and so anytime a change happens, you get notified. But if you just use once, it says just give me the value, whatever it is right now, and then disconnect the listener. And that's good to sort of save resources if you don't have a need to actually be actively notified when these changes are happening. Similarly, I get a snapshot. I'm just going to convert that into a list of tokens, and then, and then I'm going to send those to Firebase. So this is the structure of what a notification looks like when you send to Firebase Cloud Messaging. You give it a title, you give it a body, so piece achieved, together at last, and then for the icon, I'm going to use the URL of the image that we just created. So that sort of stitched together image with the heart. I'm going to put it in the notification itself. And then here we tell Firebase to go ahead and deliver those. So let me deploy again. And while that's happening, I will show you how we register that device with Firebase so that we can send it notifications. So I pulled this out in messaging.js as a separate file just to kind of clean it up, but it's still that same client-side app that we were working with. So first I'm going to request permission from messaging. And if the user says no, so it prompts them in the browser, would you like to get notifications from this particular app, this particular site? If they say no, then you can catch this here in the error and set some condition right so your app still functions. However, if they say yes, I will give you access to send notifications. Then I'm going to call a save token function, which is this. And this is going to call the Firebase messaging SDK from the client, get the token that Firebase is generating automatically for us. And then now I'm just going to write it to the database under /notification tokens and then the token. And then I'm just going to say true, this person wants to receive notifications. So let me refresh this. All right, and wait, did I save that? So we should. Oh, it's not writing the notification. Where's my error? Permission denied. Oh, that's good. Oh, wait a minute, hold on. Don't do this at home. So I have, there's security rules in Firebase to limit who can write what. And I forgot that I had secured my application, like an idiot, which you should actually do, but for the demo, it kind of got in the way. So this lets anyone write to my Firebase database at any location. So not recommended, but that will get us around this problem. So let me refresh, and you should see, there we go, instantly, I now have a notification token, so that Firebase knows where to send a notification to. This represents my specific browser. So if I take the same URL, and I go to like Firefox, for example, and I open it, it probably will ask me, yes, I want to now allow notifications, and then you can see now there's another device there. So this represents each sort of instance of your application, like per browser, and that's called a device ID. So now that that's happened, let's make another search. So what's another one? I live in New York, so let's say NYC, in London. So again, this is calling the API. The API is generating an image, setting it to storage. Storage is now triggering a function to write to the database. That database write is going to trigger a function to send a notification. So let me get off of this page, because the notification by design won't necessarily show up if the user is actively using your app. It's designed so they've minimized your page or they're on another tab, then they get the alert, right? It's kind of annoying if you're using a site and the site is alerting you with pop-ups. It's obnoxious. So by design, it will just notify you when you have the page closed. So you can see it just wrote that third item. And then if we look at the log, we should see, we should see send notification get called. So it just started send notification. So send notification is not quite as real time as the database. It may take a second because it's not a guaranteed instantaneous delivery, but it should happen pretty quickly. We should get a little pop-up here that shows us. There we go. Piece achieved, together at last. And it has what looks like a little icon of Empire State Building and Big Ben. Oh, that's kind of cool. So let's go to our app and see if it updated in the database as well, and it did. So very, very cool. All right, just one more thing I want to talk about, which is auth. You also can trigger Firebase functions on authentication events, so specifically when a new user signs up. And I won't necessarily go through the whole Firebase function, but just to kind of make you aware. But it also gives you out-of-the-box authentication, which is really, really nice. So I'll show you how easy it is to add auth to your application. So I also have this auth.js included in my client app. So I just for the functions, and you also can do Firebase deploy hosting. That should just take a second. So this is going to put this out on the public internet, and then we can all go submit our awesome combinations of two things to make some peace and harmony in the universe. So here's our URL, pvjelly.firebaseapp.com, which I have put up as a short link. So if anyone wants to go to this right now, we can do a live demo for the next 30 seconds. bit.ly/pb_j. So bit.ly/pb_j. And I will go to that myself. So bit.ly/pb_j. Uh-oh, did that not work? Is that working for anyone else? Oh, I had extra J in there. pb_j. So I can do another one. I will do Paris and Prague. No idea what this will come back with. And we should start, if anyone else is doing it, we should start to see these come in. Come on, internet, let's do this. Oh, I see some logs, some activity. Oh, here's some coming in. All right, there. Be nice, everyone. Oh, look at that, super cool. So we can see our exciting combinations, and Google, Amazon, very original. Microsoft, that's funny. Look at all this harmony and peace we are achieving throughout the world. Cheese and toast. Wow, it's hauling through with all kinds of exciting things. I have not. Okay, there's some political ones which not unexpected. So just like that, we have an app that is rendering images server side. It's sending notifications. It's doing a real-time update for everyone. Really, really easily, and all serverlessly without having to manage any servers or any infrastructure. And I feel like I should probably get off the screen before anything else weird happens. Oh, and
driving, walking, or whatever, and actually change our maps to fit the moment that the person wants to do things in. So the real-time routing is a classic example. We have real-time, rich, reliable data coupled with powerful machine learning solutions that allow drivers to route around real-time problems. And they may be updates from a product like Waze that you'll see in the application, or it might be updates that we detect from the many users of our applications. So the canvas for all this real-time information is our model of the world. Advancing technology has enabled us to go beyond the digital to dynamic and then real-time updates. And the underlying model of the world has also become more complicated and more sophisticated to be able to supply that. So I suppose, I think, and I hope, you will be thinking at this point, so how do I take that information? And how do I use it? Well, there's a very good example that I can show you here. Booking a restaurant. We're going out for dinner tonight. We might want to go and check the restaurant to go out to. So in the Google Maps application, we bundle all these solutions together. We find a restaurant based upon your location. We have information about that restaurant that we keep that is updatable by merchants, you know, and they can own that information. So in this case, they provide a menu. We can read the menu. We can even check how busy that restaurant is, depending upon, you know, the people in it. So in this case, we have a popular time. On Thursday, we see, you know, we know how many people are on average in that restaurant. But if we look now, it says it's a little busier now than in the previous one. So we know that if we go there might be a wait, so it might alter our choices. We can even go and book a table, which will go off to another app that's been enabled by mobile technology to take a booking without us having to phone anybody up. I have a mobile phone. I think phone and mobile don't really go together for many people nowadays. It's just a mobile data device. So I can book a table, and then finally, I actually have to get there. So from within the app, I can hail a ride. And all of those functions are enabled by an increasingly sophisticated model of the real world, powered by Google, and then using that model that we have and the technology we've had at Google, we're able to power some of these parts of the solutions, from understanding better footfall data, connecting with applications that might take you to a place, and in their turn, they use Google products to actually do the routing of those rides. So, that's how you as a consumer can use our technology in the palm of your hand to unlock, you know, different services. How can you as businesses use our technology? So, if you have a look at the progression, you can see how it all fits together as a sort of like, I want to say a tidal wave, but like a nice swell of information that you can surf along. We've got technology marching along at the bottom, steadily improving and raising the bar for developers. Riding that wave, you have an increasingly sophisticated model of the world, with more real-time data about the global environment. And with those, we can create new possibilities to emerge. And we provide APIs and solutions and a platform for you to analyze your data with those APIs to power your new technology. So how can you get access to this? So we know, and the examples of how developers are doing this, yesterday you hailed a ride by standing in the rain, hoping that somebody would stop. You know, they never did for me, I get the tube. So today, you can use an app to get your ride. And that app can tell you what type of car you can see is nearby, how long they're going to take to get to you, and potentially how much it's going to cost you. Something that is really important to you for knowing just, can I afford to take a taxi home? Yesterday, you know, controlling the heat in your home was a matter of setting a thermostat and going out, or making sure you turn the thermostat off, or having a set of timings that would like work all year, or forgetting to change it as it became winter or spring, or having a cold house or a warm house. There was no control, you know, a basic level of control. Today, machine learning, understanding how you set your data, and actually the position of where you are and where your device is can all be used to actually control the heating of your house and actually save money on that heating. We'll only heat the house up when you're coming back, and we know you're coming back because the application will know where you are.